Good morning students. This video is based on the numerical problems of the chapter Physical Quantities and Measurement. Okay. So I came to know that some of you are facing problem regarding this numerical problems of this chapter. Okay. So I have shown some examples so that you can understand the basic idea to solve this type of numerical problems. Okay. To solve any numerical problems of this chapter, you have to remember this basic formula. Okay. What is the formula? The formula is relative density is equal to density of substance by density of water at 4 degrees centigrade. Okay. Or you can write it in this way, that mass of substance by mass of water at 4 degrees centigrade, or volume of substance by volume of water at 4 degrees centigrade. That means one formula can be represented in these three forms. Okay, the formula is basically same. The comparison, the ratio between density of substance and density of water at 4 degrees centigrade. Okay, so relative density is density of substance by density of water at 4 degrees centigrade. But it can be written as mass of substance by mass of water at 4 degrees centigrade, or volume of substance by volume of water at 4 degrees centigrade. Three formulas are same, but they are written in three different forms. Okay. So this is the basic formula to solve the numerical problems of this chapter. Okay. Now I will go to the first example. Series. An empty specific gravity bottle weighs 32 gram in a physical balance. That means the weight of the bottle is 32 gram. Okay. When it is completely filled with water, it has a mass of 72 gram. On filling it with methanol, the mass of the bottle is found to be 64 gram. Calculate the relative density of the methanol. That means the ratio between the density of methanol and the density of water at 4 degrees centigrade. Okay, we have to find the ratio between the density of methanol and the density of water at 4 degrees centigrade. Okay. So to find the density, to find the relative density of methanol, at first we have to find the density of methanol. Okay. So to find the density of methanol, we have to know the value of two variables. What are they? They are the volume of methanol and the mass of methanol, because we know that mass by volume is equal to density. Okay. So an empty specific gravity bottle weighs 32 gram. Okay, so the weight of the bottle is 32 gram in a physical balance. When it is completely filled with water, it has a mass of 72 gram. Okay, so the weight of the empty bottle is 32 gram, and the sum of the empty bottle and water, that means bottle plus water, the mass of bottle plus water is equal to 72 gram. Okay, so the mass of water is 72 minus 32 is equal to 40 gram. Okay, the mass of the empty bottle is 32 gram. The mass of the bottle plus water is equal to 72 gram. So the mass of the water is 72 minus 32 is equal to 40 gram. Okay. Now you can see here that on filling with methanol, the mass of the bottle becomes 62 gram. Okay. And we know the mass of the empty bottle 32 gram. So the mass of methanol is equal to 64 minus 32 is equal to 32 gram. Okay, so we got the mass of water 40 gram and the mass of methanol is 32 gram. Now relative density is equal to mass of substance by mass of water at 4 degrees centigrade. Okay, so we can assume that this water, the temperature of this water is at 4 degrees centigrade. Okay, so the relative density of methanol is equal to mass of substance by mass of water. That means mass of methanol by mass of water is equal to 0.8. Okay, so see, in this example we had no need to find the density of methanol separately. Okay, we just compared the mass of methanol and mass of water and got the relative density of the methanol. Okay, now in the second example, see, find the relative density of a piece of wood that has mass of 25 gram and volume of 29.4 semi-cube. Okay, so it is quite easy. Here mass is given and volume is given, and we know the density is mass by volume. So we just divided the given mass by the given volume and got the result 0.850. Okay, now in the second portion, find the relative density of a piece of wood. Now we got the density. Okay, now we have to find the relative density. That means the comparison between the density of the substance and the density of water at 4 degrees centigrade. Now you go to the density of the wood is 0.850 gram per semi-cube, and we know that the density of water is 1 gram per semi-cube. Okay, so we got the relative density of that substance is 0.850, same as its density. Okay, that means in CGS unit, what will be whatever the density of a substance will be same as the relative density of that substance. Okay, so in CGS unit, the density and relative density will be same because the density of water at 4 degrees centigrade is 1 gram per semi-cube. So dividing by 1 will be given the same result. Okay, now in the third example, see, the density of mercury is 13546 kg per meter cube. Find this relative density. Okay, so relative density is density of substance by density of water. Now here it is given in SI unit. Okay, that means in kg per meter cube. So in SI unit, the density of water is 1000 kg per meter cube. So you shouldn't make